Welcome to section 3 of the course. Since you mastered the fundamentals in the last section, it's time to move forward. We'll be diving deep into React's core concepts such as lifecycle methods, exploring how the reconciliation algorithm works, and learning common must-know techniques such as prop drilling and state lifting. In this video, however, we're focusing on understanding lifecycle methods, and there's 3 interesting real-world examples that we'll code out today. Now, to give you some background before we dive in, a component has a lifecycle. At the start of it, the first step is the rendering and mounting process the component must go through. And somewhere at the end, the component must also unmount and leave the DOM. You've seen it with our form component when we introduced conditional rendering. We were removing that form from the DOM, causing it to unmount and lose all of its state, basically destroying it. The same will happen when a user navigates to a different page, for example, causing a new page with new components to appear. But somewhere between these two moments, a lot of re-renders may or may not occur. They usually do. And as you might expect, there are a lot of lifecycle methods that you can hook into during this stage. But the basic core skill you need to learn right now is related to the mounting and unmounting stage. When mounting, remember that the order of operations is the following. First, the constructor is called, then an initial render is performed, and then the hook for component did mount is finally called. When a component is about to be unmounted, the component will unmount hook is called. Notice that there is no component did unmount hook, since by then the component no longer exists, and such a hook would be irrelevant. But there's many other hooks in the React API, although we can cross off 3 that will be deprecated in React 17. There's no need to worry about these, and there's another 2 that are situationally useful and not relevant for us right now, leaving us with 5 hooks to cover. We'll cover 2 of these in another video, leaving us with 3 core lifecycle methods to cover in this video. And these are likely the most important ones that you must absolutely know as a React developer. Let's start with an easy one. Component did update. This is an easy one to cross off our list first. As you can see, I am in our text input field component and I've defined a method called component did update. This is my hook. This method will be called whenever the component updates. The 2 parameters it's passing down to me are the new props and state. I'm just logging them to the console right now. Since the state is undefined in our component, I'll just initialize it with a temporary value to confirm the logging works. Now, this hook is mostly useful for debugging and monitoring, but I often see people trying to include logic here and modify their state based on the newly updated props. This often leads to mistakes, like the badly written code I am typing right now. What do you think will happen when we let this run? Yeah, so that's as close as you'll get to a Stack Overflow without React stopping you and throwing an error. What we did was create an infinite loop. We were causing a new update every time there is an update. Sounds silly, right? Now, while I did do this intentionally, it is also very easy to make this mistake by accident. So my rule of thumb is to just never do anything like this in component did updates. It's usually a red flag that you're doing something wrong in the first place. Let's move on to our other 2 hooks, did mount and will unmount. I'm going to be a good Boy Scout and correct a mistake that was left over in the previous code. I'm going to update the default value of isFormVisible to false to have it hidden by default. Now, since we're hiding our form via the visibility property, we're going to run into a styling problem. Elements that have a visibility of hidden still retain their height and width. Notice how this paragraph will be way on the bottom of the form even though the form is supposedly hidden. Maybe you want this behavior, but probably not. The fix for this is simple. We should use the display property. Great, so now our kitchen sink is clean again. I'm going to return our list component, but this time I don't want to render data from a file. Instead, I want to load it via an external source, such as an API, and save it in the local state. So I'll initialize an empty jobs array in the state and pass that down to our list component. Next, I'm going to create a mocked API for testing. Let's create a new directory called API in the source directory, and then a new file called jobsapi.js. In this file, I'm going to export an object. This object will have a method called getJobs, and I want this method to return a promise that will resolve after 2 seconds. We'll accomplish this using the setTimeout function. And of course, I need to import the jobs array that I want the method to resolve. Now, a quick quiz. Notice anything wrong with this code? We're actually calling the resolve method right away, so this promise will resolve immediately. Remember, we need to provide a callback that calls resolve, like this. Okay, back to our app.js component. Let's import this file. And remember, what we're doing here is we're imitating a call to a server, so we're imitating an API. If you're not familiar, this technique is called mocking. Now let's define our hook for component didMount. We're going to call the jobs API from here. This is the first common use case you'll see for using lifecycle methods. It's okay to execute operations like this from within this hook. Once the API resolves, we'll set the result to our local state. That works, and as you can see, there is a slight delay. Now, since create React app lets us use the latest JavaScript syntax, let's convert this method to async await. Alright, much better on the eyes, a lot more pleasing, easier to read. One more cool thing you can do here is also use the component didMount hook to handle your loading animations. So let's add a key called loading to the state and set it to false. Then let's set it to true before we call our getJobs method, and then back to false after the promise is resolved. Okay, so what are we going to do with this? Well, in our render method, I'll make it so a crude loading indicator is presented if loading is in progress. Notice how loading shows up for 2 seconds and then our component renders. I invite you to pause and play around with this for a bit. Add a nice spinner, for example. Go ahead, I'll wait. Back? Great. I'm going to remove this for now, and also get rid of the waiting time by having the promise resolve basically right away. Okay, so that was use case and example number 1. Let's go on. I'll create a new file called timer.js. Inside, I'm making a regular React component, just like we've done so far. But I'm also going to initialize the state with a date object that's equal to the current date and time. In my render method, I'm just going to render this date and time in a simple paragraph. But I want this to update in real time. So I'm going to declare my component didMount hook. Inside, I'm going to set an interval. And every second, I'm going to update the state with a new date object. So let's go to our app.js file and add it in. Okay, that seems to be working, but it's showing the date instead of the time. Let's see what the problem is. And oops, I meant to call toLocalDateTimeString here, which is a method that returns the current time in a format that fits with the current locale. Now that I've fixed that, we can see the timer ticking properly. So, quiz time again. What will happen if this timer is unmounted from the DOM? So I'm going to hide our form and instead use the show hide button to add or remove the timer from the DOM, just like we've done with conditional rendering in our initial video. Now let's remove it. Uh-oh, what's that scary red error in the console? Well, our timer component declared an interval that called thisSetState. Now that that component is no longer in the DOM, the setState is referencing an undefined context. Now we can fix this. In our component didMount hook, we will assign the interval to an internal property. Then we're going to declare a component will unmount hook. We will call clearInterval here. This will remove the interval and the function associated with it. So now as we toggle the button, we can see the timer works great and there are no errors in the console. This was use case number 2. While intervals are generally a code smell in my opinion, chances are you will be using them and this is the proper way to do it in React. We initialized one in component did mount, and then did our cleanup in component will unmount to prevent errors and leaks. Now use case number 3 is rather similar. I'll remove the timer for now and create a new file. I'll call it resizedemo.js. And I'm going to copy our timer component and delete the lifecycle hooks and rename a few things. Okay, that looks good. So instead of having a date in my state, I'll have a key called window width, and I'll have it be equal to the inner width of the window. I'm also going to display this value in the render method. Now, I want this value to update when the window is resized. So how do we do that? Well, I'm going to assign an event handler for the document resize event within component did mount. And we'll update the state with the new width like so. Great. So let's add the resize demo component to our app file. And for easier demonstration, I'll remove all the other components from the file for now. Okay, so as I resize the window, you can see the value is updated. Do you know what that means? Pop quiz time again. So if we use the button to mount and unmount the resize demo component from the DOM, will something bad happen? And you can probably guess that it will. So as soon as you resize the window, there is an error in the console. This is the same deal as earlier. The event listener is still active, but is referencing a non-existing object. So let's code a quick solution. We'll first extract the setState operation to a separate method so we can have a reference to it. Then we will add the code to remove the listener in component did unmount. Let's just test that out real quick. Awesome. The event handlers are being cleared properly and there are no leaks. So I hope you enjoyed those examples, and I invite you to go over the code and code out your own ideas.